Okay, I hope you had a good weekend, and we now are in the final week of classwork. Next week, of course, will be going into our last week, and so I think they're going to send out an announcement, and I'll be announcing as we go along that the due dates for everything coming in for the last that you can turn things in. So be watching for that. I had you watch the last couple days some videos on grass. Part of that was because visually, it's hard to kind of do some of that where I can make the videos, and there's good resources online for stuff like that as well. So they showed, they're able to put those on there and kind of go through the grass and visually go through some of the pitfalls and then some of the reasons why you'd use certain grass. I did want to kind of highlight that for a little bit today and have you take some notes and just kind of go through some things that even the videos may have touched on a little bit, but kind of put it in our own classroom setting. And then one other thing I'm going to put at the end to just show you something you can do. It's actually kind of neat once you learn how to do this thing at the end that I'll show you. But as you can see, graphs can be misleading, and hopefully the video showed you different ways that just because you see a graph or a chart does not necessarily mean that it's a perfect graph or oh, I have to believe completely what that is put up there. They just depending on the what they used or the things that they put on there, it could be interpreted in different ways. Polls are the same way. When I hear political polls, I'm always my math brain goes up a little bit in the way of okay, what is this trying to portray as far as the numbers? Do the numbers add up? Is it truly what they say it is? And not that I base anything on really polls anyway, but if I am looking at the polls to just see information, how is that information being presented? So an example, and I think I shared this one before, but if I said 50% of people, 50% of people, has a lot of things to it. Like, what does that mean? Like 50% of the people said yes, or 50% of the people said no. And a circle graph, I had an extra one because circle graphs are something you see very, very common, especially with polls and different things, is a circle graph. So if I had a circle graph and I said, hey, I walked in somewhere and I said, 50% said yes and 50% said no. And if I was trying to portray something, that is a visual that clearly everybody can see. Okay, half the circle, half the circle. But there's other things that are needed to know just beyond that. If I walked into a board meeting and said, hey, 50% of the people said yes or 50% said no, or even if I said 80 and 20 or something like that. But in this case, let's say I walked in and said that, business may think, oh, well, we've got a lot of people, just as many people want it than don't want it or something. But then you may dive in and find some other things that maybe I only asked two people. Maybe, I just walked up and the two people I work with, I said, hey, what do you think? And the one's yeah, and the other's no. And I'm like, oh, hey, 50%, 50%. Well, that doesn't tell you very much because two people are going to often disagree. So maybe that's why it's split that way. But as you go on, maybe if you asked your whole office building, maybe 80% said yes, or and maybe the two people that work by each other just never are going to agree, and that's why I got 50-50. So that's why you have to ask more than two people. And if I want to use this as hey, the office feels this way or kind of thing. So for one, it can be misleading. That doesn't tell me anything about how many people I asked. So it's good to know maybe 1,000 people were asked. Well, at that point, then it gives me a better reading, and so that's what I would watch for in the case of more information that I need than just the visual graph. Another example that I could say, let's say I used this before in the school, and those that know the school, I just thought it was kind of a neat little example, kind of give you an idea. The back parking lot, when you pull out, okay, you're pulling out onto a street, it gets kind of busy sometimes. It's a small little street, but it stays pretty busy. And let's say I was going to do a poll and call the city and try to call as many people in the city as I could and say, okay, should we put a traffic light right there, just in the parking lot kind of thing to pull out. And of course, I start calling people just to get an idea, and I'm going to take it to the city board and say, okay, I want to bring you this information, And the first thing is, let's say I asked a lot of people, so we covered that. What if I asked 2,000 people or something? So I had a good basis. But I walked in and I had it like this: 50% said yes, and 40% said no. Now, the video should have went through this. That is it's not only misleading; it's an incorrect graph. This is not 40% of the circle. And so, for one, if I took that to the city board, I'd be thrown out right away, just because hopefully they'd say, well, no, you're showing it as equal when this is less, okay? So a circle graph has to use up 100% of the circle. And one way to do that is, let's say any poll you take, let's say it is a yes no question you're asking, and that's all you want is yes no. You're going to find out whenever you take a poll or a survey like that, you will always have those people that just answer, I don't know, or I don't really have an opinion, or I don't want to say yes or no. I kind of feel both way, or maybe. You're gonna always have people that just don't want to be put to a yes or no. So you've got to include those people. You can't just say, well, I'm just going to leave them out and not show them on the graph. You've got to include them, and most likely that's what that other 10% was, and that's the word we use. So in that case, your graph's going to look more like this, okay, where you've got 50% said yes, 40% said no, and then you've got this 10%, and you're going to mark it other. You'll see that a lot of times on the thing. Another thing that other covers is you will always have a few people that will just answer nonsense. I mean, sometimes it's a joke, sometimes it's maybe not a joke, but they'll just say, like, should we have this traffic light? And they'll go chicken, or Mickey Mouse or something. So they're going to answer something that does not even fit into a category. And you can't, you don't want your circle graph to have so many slices, especially there at the end where they're all small, to try to include every single answer, like Mickey Mouse, 0.5%. And chicken 1%, and like, you don't want that many small slices to try to include every single answer. That's why you usually see a category of 10% other, and so that includes the people that just didn't want to answer or weren't sure, and it also includes the just offbeat answers that you'll have in there. So that is kind of how that breaks. Now, if you had 30 or 40% say I don't know and maybe, you may need to go ahead and make that a category of its own. Like, if you had that many people say I don't have an opinion, I don't want to answer, or maybe, you may need to make 30% maybe, and then still have your like 5% of other, which were offbeat answers. So you kind of have to weigh that out on each poll. So here we've got our poll here though, and let's say I took this in and I said, okay, we want to build this traffic light. So now our poll, our graph's more representative. It's not misleading necessarily. It's we're trying to get as close to the information as possible. If I went in and said this and said, now there's more people that say yes than no or maybe, because the maybes, there may have been a few that wanted it kind of but weren't sure. So on this, let's say I pushed and said, I think we should build the light. Well, you got to dive even a little deeper than that, okay? And you're going to find out that that's why the more specific, the better it is. If I broke it down more into this, and maybe instead of just asking yes or no, because here's the thing with this. Let's say we did this, the city built it, and you got a lot of complaints. Because part of that is maybe the people that said yes, there may have been half of those people that were like, yes, but I think it should be done this way. And yes, but I don't think the city should pay for it. This breaks down into a lot of categories to where you could build the light and say, well, we're going to have more people happy about it than unhappy. But then you got to count into that you're probably going to make some of these people unhappy just because of the way you did it. Maybe you put it in a place that they weren't really, I didn't think it'd be there, or I would have moved it 10 feet this way, or we have to pay for that tax money. So, I mean, you got to kind of look and say there's a lot of other factors. A yes, no question doesn't always answer that. So let's say I went in and said, okay, let's look at it more like 20% said strongly yes. Okay. and 30%. And this is gonna look. I should probably. Well, and the hopefully that's why I had the video do the things of how you break it down angle wise. You know, it's a 300 or 360 degrees angle, so you've got to work out those degree measures on how this should look. But I'm not going to spend that time, you know, with the board here to try to do that. And then let's say 20, the 40 here. So 20 said no, and 20 said strongly no. And then you had your 10% other. So let's say you went in with this. This would be a little more representative. It's the same percentages. 50% said yes, but now you find out that 20% were really on board. No matter what you did, they were like, yes, a light needs to be there. And then maybe this 30% are a little apprehensive. They said yes, it's probably a good idea, but you're going to have dissension there. You're going to have people saying, well, you did it wrong, or I didn't really mean for it to be paid for through the tax. I mean, that kind of shows you more that you may not want to build it, even though you have 50 and 40. It may show you, you know, hey, and this one broke down evenly, so you're going to have a lot of people in this strongly no in that case. So this shows you how you can break into graphs a little more deeper and try to do the math and realize the math matters on it. You know, another thing about polls that I want to highlight is just the way you ask a question can be misleading to, you know, to put on a graph. I recently, you know, I had to do a checkup at a doctor, and I have just a medicine prescription. It's not anything. It's just, you know, you gotta go to a yearly checkup, and so I was doing that, and they go through these list of questions, and some of them I'm like, wow, you know, that's a little invasive, but you know, one of them, I just remember the way it was worded. I thought, now if I answer yes, that's gonna sound bad, but truly the answer is yes. Like, and I'll give you an example. There's several questions like that, but it said, have you not had feelings of lethargy or tiredness? You know, have you been lethargic? You know, and I think, okay, if you not had feelings of that, and I'm like, well, I want to answer yes. You know, I'm fine, and so I finally looked at I was like, hey, I'm fine. Like, you know, you just had to say, however you asked that question was silly, you know. Now, if they asked, are you feeling tired? Then you could say no. You know, it's a little more easier. But when you said, have you not had feelings? You've got to answer yes to something you've not had. So it can get really confusing. So, you know, that can be one thing, that just the way the question's worded. I made one up that said, you know, you could call and ask people and say, do you agree that all speeders, people that speed on the road, should be fined? And just that question, do you believe that all speeders should be fined? Well, you could have people start to say, no, you know, like, I don't think all of them should. So a lot of people may say no because you said the word all. And so you take that information and say, hey, people, you know, and maybe 80% said no, because, you know, most people would think, well, there's probably some reasons why you should be able to speed, like maybe you're trying to emergency, or something happened in the hospital, or you're trying to get some, you know, and so they may have answered because of that, because your question was kind of worded bad, where you said all speeders should be fined, and so they answered no, and so 80% said no, and you go and say, hey, look, 80% of the people thinks that speed limits should be revoked, you know, that there shouldn't be any speed limits, because they answered that no, you know, people shouldn't be fined. Well, your question was off. You know, you were asking if all speeders should be fined, and people were thinking like, well, there's some that shouldn't be, and not that they're against speed limits, but they're against, you know, everybody being fined for that. Same question could be misread the other way. If you say, maybe you're doing a thing and you say, should all speeders be fined, and you pose it in the way of, you know, let's say someone's well connected or rich, or they just, you know, or should they be let off and just everybody else have to pay? And in that case, people may answer and say, yes, everybody should be equal. All speeders should be fined. And you go and say, see, look, everybody is for speed limits. You know, just that word all can make you go wrong in one way and can make you go wrong in another way. So you see that just the way questions are asked. You've got to really pay attention to the polls and to the graphs that represent that. Try to be as specific as possible. Visual things like the bar graphs, they showed one I thought was really good when they had these numbers real close together, and it looked like, or and it looked like this. But then when you really dove into it, the graph should have looked more like this, just because the numbers were more representative that way. So just visually, there can be things. Even the numbers. Let's say you ask 1,000 people, and I told you that was a good amount of people, but there's still even qualifiers for that. What if I asked 1,000 people from California something, and then I asked, people from Missouri? Well, yes, you asked 1,000 people, maybe 80% said this in California. You may not have those same numbers in Missouri. You want to kind of know where did those, 1,000 people live, or what were their leanings, or, on that. So that's another thing you have to pay attention to. I basically, I look for, when I look at graphs or polls, I look for number of people asked. Okay, first off, did they ask a lot of people? Okay, so, and they should show that, most now start to show, out of 1,000 voters, or, out of 80 doctors or something. Their leanings of the people asked, so they may put, and I'm not saying you have to, but, and I'm not giving you an opinion of which ones I lean, but, does it say Democrat, Republican, Independent, Libertarian, Conservative? Does it say how they lean, or that area? And so that's kind of the political question, or just the location. Maybe it's not even a political question, but I kind of like to know who'd you ask? Did you ask people that don't even have the same kind of problems that this area has, or so leanings or location. And then you'll see a margin of error. That's another thing I look at. Okay, margin of error. And they'll have this thing where they'll have a plus minus, and they'll say like 3%. Okay, margin of error. That means that because of the other things and different ways, and that's still an estimate. It's not a perfect estimate. So don't necessarily think, well, that's perfect. But it does kind of give you that they could be 3% wrong the one way. Maybe they answered 3% to the one way too wrong, or 3% the other way, which means they actually have a 6% swing there, because it's 3% one, 3% that could be off. So if you see like a margin of error of like 10%, that's pretty bad, because it could be 10% above, 10% below, so a total of 20% that could be off. So, and I apologize if your eyes are, I just hit this board, so if your eyes are going like that. But so those are three things I mainly look for when I'm doing a poll. And I want to go through those. And really, guys, this material, these 3 days, I thought it was I thought it would be good for applied math. We're not necessarily going to be testing big time on this part, just because there's no good way to do that online. But I thought it was good to look at, because it's everyday things you run into, and it involves math, that the math does help you break into that. The other thing I was going to put up there is, and I'm going to have you try this, and I'll explain it here in a second. Now, on today's assignment, if you'll just upload your notes, or even your work of trying this, and I'm going to show you what I'm going to have you do, that's going to be your assignment. So you'll upload your notes, and even if you tried this, you can put that up there. There's not going to be like problems to do, so that's where I'll count your attendance. There will be an assignment just to upload this for. That's shoes. So metal cleats and plastic cleats and running shoes. So what I did was I put, here's a softball team, and this goes in statistics too, and that's why I put it in here. But you got a softball team, and they have these for their uniform. Okay, for hats they have a red and white hat. For a jersey they have a red, white, and gray jersey. For pants they either have white or black pants, socks, so on, red, white, gray, and black. And then their shoes they either have metal cleats, plastic cleats, or maybe if they're playing on some turf and different things, they have some running shoes. Okay, so here's their jerseys, and they have to, depending on the environment or what they're playing, or home team or away team, they can dress different ways. Now, how many different, this one may have you do it. What you can do now, I will say this, don't spend a lot of time on it. So I would just pause it, and I'd put like a 5-minute limit, see if you can come up with this. Because I did this in class one time, and it could have went all day. But I want you to try it. Don't spend a whole hour trying to go through and figure out. But how many different ways can you combine this? So, give you an example. Let's say I wear a red hat, and then everything up top, red, white, red, metal cleats. So that's one way of wearing my jersey. But then I could wear a white hat and everything on the top row. So that's another way of wearing my jersey. But then I could wear a red hat, just change my shirt, and wear everything on the top row. Or a white hat, white jersey, and everything on the top row. As you can see, there's a lot of different combinations. I could then wear a red hat, a red jersey, and then just change this and everything on the top row. Or, a white hat, red, And so you're seeing there's just, if I just change one thing, how many different jersey combinations can I wear? So I'm going to have you work on that. 5 minutes tops. Just try, see if you can come up with the answer. Tomorrow I'll post the answer and show you there's actually a quick way to try this. So do this and then upload your notes from the graphs that you took that I went through and that'll be your assignment for today. Okay, thanks guys.